Hello everyone. Today in the subject of industrial biotechnology, we are going to study about ABSL biosafety. So when dealing with this particular topic and why biosafety is required in the experimentation procedures. So outcome of this topic will be you will be able to understand the main concept and containment uh, facilities in depth. So principles of biosafety. Biosafety is the prevention of a large-scale loss of biological integrity, focusing both on ecology and human health. So, when the biosafety is concerned, it is a large loss of biological integrity, focusing both on ecology and human health. So, how these pandemics and epidemic occur? So, they are just outbreak of some external or some alien or some what do you say exotic species of pathogen that comes to the that very particular agent, or it can be native also, and it flourishes in a very uh, odd way, and it overcomes all the scenarios and all the population of the pathogens that are present locally, and sometimes it can be global also, like coronavirus pandemic in the current scenario. These prevention mechanisms include conduction of regular reviews of biosafety in laboratory settings, as well as strict guidelines to follow. So these prevention mechanisms include conduction of regular reviews of biosafety in all laboratory settings. So it is not like that once you have established a biosafety uh, unit in the laboratory and it will keep on working, and you don't have to take care of it. So every time you have to inspect the things, and every time you have to see that everything is working according to the standards. Nothing is anything that needs some uh, attention, anything that needs some sort of servicing. So every time you have to be concerned about the not only your safety but also for the safety of the individuals who are working in that very containment facility or laboratory. So, as well as strict guidelines to follow. Most of the time, guidelines are very strict in nature, right? You are working in any type of facility, as we have covered the concepts of BSL 1 to 4 facilities and what are the integrate details. So, you might have seen that every time the requirements and the guidelines are getting stricter and stricter with the increase in the risk group of the pathogen that can be exotic and that can be native also or indigenous also. Biosafety is used to protect from harmful incidents. So the main concept of biosafety has been developed in order to work on harmful incidents, or when you are working in pathogens on pathogens that are indigenous in nature, that can be exotic in nature, and you don't know their nature and you don't know any cure of them. So in that very particular setting, every time the researchers and the scientists in those containment facilities, they constantly work on them in order to find a cure for the solution, in order to understand the life cycle and the mechanism of that very pathogen. So these facilities are playing extreme role on the forefront of these things, right? Many laboratories handling biohazards employ an ongoing risk management assessment and enforcement process for biosafety. So, what they are trying to do is that each and every individual who's working in the laboratory understands the scenario, understands the functionality, and understands the pros and cons of working in such an environment. Right? So, before working in such environment, the individual is required to receive a proper kind of training. Individual is required to be well versed in the procedures that he or she is carrying out. Okay, they should be properly vaccinated, and they should understand that how to learn in such scenarios, and if any accident happens or any miss happening takes place, what are the safety measures that they have to follow without losing their cool. So handling is very important of these biohazardous material, and that is why containment facilities have been developed. Okay, so risk management and enforcement of the procedures of for biosafety is very much important, and this is how we will be able to develop the cure for these contagious outbreaks that are affecting the human population after a regular interval of time. So failures to follow such protocols can lead to increased risk of exposure to the biohazards or pathogens. So, if an individual is very careless, he or she is not at all worried about in what facilities they are working and what are the protective measures you should take and how you have to ensure your own safety. So, this can lead to some sort of serious accidents also. Okay, and exposures that that can lead to a very lethal condition and sometimes death also. Human error and poor technique contribute to unnecessary exposure and compromise the best safeguard into place for protection. So, if the individual is not at all properly trained, if the individual is not at all aware of what they have to do in what particular type of condition, then the scenario is very different. Okay, before jumping into such kind of situation of biosafety, you must learn that biosafety is designed for your protection. Okay, it is designed for your own benefit and your own safety. As in the image, you can see the symbol of universal symbol of biohazard. Okay, if you are carrying out experimentation on pathogens, you can easily see these kind of symbols placed on the laboratory, placed on the equipment, even on the waste disposal bags also and bins. So whenever you see such type of symbol of biosafety or of biohazard, you have to be extremely cautious to what are the things that you are doing, and you should be aware of the steps that you are taking. So, principles and concepts. This section defines biosafety concepts including biohazardous material, virulence, route of entry, viability, infectious dose, concentration, immune status, biosafety containment levels, PSL 1 to 4, and ABSL 1 to 4, right? And infectious agent risk group RG 1 to 4. So, what they are trying to explain to you here, biohazardous material and virulence, pathogens, and all those things, they depend on route of entry. Okay, like for example, if we take coronavirus, okay, coronavirus require it readily targets your respiratory system. So it needs to enter that very surface. So that is why you are wearing mask these days. Okay, infectious dose in what amount that very particular pathogen or virus or bacteria will cause infection, because it also once it enters your immune system, it also have to once it enters your body, it also has to evade your immune system concentration. Yeah, after that it has to anchor into your system and increase its number. So concentration will be increase and immune status. So immune system is of what type? If the individual is having very sound and very strong immune system, If the individual is suffering with many other diseases and his or her immune system is not up to the mark, then there is an issue, right? So, biosafety containment levels, PSL 1 to 4. So, containment facility means we are working in a setup or a scenario uh, where harmful pathogens are being worked upon. Okay, that can be indigenous in nature, that can be exotic in nature, and you have to keep that very pathogen in that very facility only, in that very confined area, because uh, if it goes out, if it is going to reach outside, then it will be a issue, then it will be a problem, because it can readily affect and infect all other people and can result in some uh, epidemic or some pandemic situation. So biosafety level 1 to 4 depends on the uh, integrate details and severity of the experimentation, and ABSL facility 1 to 4 that we are going to study in this topic today. And infectious risk group organism RG 1 to 4. Risk group organisms, they also depend on the level of pathogenicity and level of contagious nature. The higher the contagious nature, the higher the RG group will be. The lower the contagious nature or non-lethal nature, the lower the RG level will be. So in this image, you can see a scientist is working in a biosuit in a biosafety cabinet and performing experimentations and uh, other protocols on uh, some lethal pathogen, maybe coronavirus. So, biohazardous material. What is a biohazardous material? Biohazardous material are any microorganism or infectious substances or any naturally occurring bioengineered or synthesized component of any such microorganism or infectious substance capable of causing death, disease, or other biological malfunction in humans, animals, a plant, or another living organism. So, biohazardous material is pathogenic in nature, is very infectious in nature. It can be natural or bioengineered in a laboratory, right? So, every time it can be really lethal. It can cause a lot of damage to the population, deterioration of food, water, equipment supplies, or other material or any kind of harmful alteration of the environment. So, in this image, you can see the biosafety levels. Biosafety depends on practices and measures, personal procedural barriers, primary, secondary barriers. So, every time the experimentations that are going in biosafety facility totally dependent is totally dependent upon the barrier methods. Okay, so scientists have created such a protocol that they stay away from the that very pathogen, and meanwhile simultaneously they can also perform experimentations on them. Here you can also see the BSL1, BSL2, and BSL3 and BSL4. So their intensity level increases from low risk microbes to high risk microbes that are very contagious and life threatening in nature. These include many things, but not limited to certain bacteria, fungi, viruses, rickettsia, protozoa, parasites, recombinant products, and many other agents that produce a lot of toxin, allergens, cultured human or animal cells, and potentially infectious agent. These cells may contain viroids and prions, other infectious agents as outlined in the laws and regulations of or guidelines. So, what is pathogenicity or virulence? Pathogenicity or virulence is the ability of hazardous material to produce or develop a rapid, severe, or deadly disease. Some material are highly pathogenic even in healthy adults. Okay, so these pathogens that are highly infectious and they can readily cause infection in healthy people also. So these kind of material are really very contagious and very very dangerous in nature. Okay, so uh, they are not leaving even healthy individuals also, whereas others are opportunistic pathogens. Okay, opportunistic pathogens mean if they are going to find some a weak individual or weak organism, they will attack it. Opportunistic pathogens able to infect only host with lowered immunity or sites other than their normal habitat. So their habitat is also normal. Okay, and they are just looking into the context that any pathogen is looking towards the individual who is not having a very good immune system or lowered immunity levels. So they are just looking for the that very opportunity to infect that individual. Some biohazardous materials are attenuated, that means weakened or inactivated. These biohazardous materials or weakened and do not produce significant disease. So that very particular nature is, or that very particular practice is used in producing the viral vaccines. Okay, they do have virus in them, but that virus has been attenuated or in weakened form. That is required to just produce that very particular trigger, that very particular amount of antibody production. Okay, that is why when you are vaccinated, you will have a fever and you will feel uneasy for the time period of 2 to 3 days. Then it will be okay. The more severe the potentially acquired disease, the higher the risk. So the severity of the disease depends totally on the risk factors. The more the pathogenic the disease is, the more the dangerous situation it can create. So routes of entry. An infection occurs when pathogenic microorganisms enters the human body in sufficient numbers. Okay, so it is not like that only one pathogen entered inside your body and it will create infection. A particular amount, a particular percentage is required in order to produce some sort of infection by a particular route which overcomes the body's defense system. They have to evade the immune system, they have to overcome the defense system. So, a particular number of that very pathogen is required. By understanding the mode of transmission, pathways from source to you, and route of entry, okay, into the body, procedures or controls to prevent exposures and infection can be developed. So it ensures that that very particular infection is going to infect you. Okay, but at what cost? Because of what? Right. So every pathogen is of particular fashion. Okay, they have their own area and their own working mechanism. So if they are going to infect that very particular, uh, what you say, particular site, so they need to have a sufficient amount of number in order to evade the immune system and to overcome the host defense system. Inhalation hazards. Inhalation of aerosolized biohazardous material is the most common route of entry into the body. Okay, during the experimentation, some aerosol is produced and you inhaled it and you are not wearing a mask properly. Inhalation of aerosol involves microscopic solids or liquid particles small enough to remain dispersed and suspended in air for long periods of time, right? So these kinds of particles, they are just carrying the pathogens. They are microscopic solid or liquid particles. They are very small enough to be suspended in air for a very long duration of time. Source of aerosol include aerosolized solid material that include spores, dust, particulate, etc. right? Liquid material. They include mist and sprays, coughing, spittle, sputum, etc. Technical processing, blending, grinding, sonicating, lyophilizing, sawing, centrifuging, etc. So while you are performing these type of activities, it is evident that you have to be really careful, not only for yourself but also for the individuals who are working all around you in the laboratory. So when you are aerosolizing the material, when you are dealing with liquid material, and when you are blending, grinding, sonicating, lyophilizing, centrifuging, certification. So you always have to be extremely cautious and always wear proper equipment that is necessary for the experimentation procedures. So, ingestion hazards, how these occur, and what are the dangerous things that they are responsible for. Ingestion of biohazardous material occurs frequently as a result of poor personal hygiene and poor laboratory practices. So this is also an important part that you have to be extremely cautious about. Proper hand washing minimizes the opportunity for mouth and eye exposures. Examples of how ingestion occurs include eating, drinking, and smoking in the laboratory. This is the most foolish thing any individual can do. Never eat, drink, and smoke in the laboratory. Mouth pipetting and suction technique. Always use a pipetting device, okay, and a suction device. Never use your mouth in the experimentation procedures. Transfer of microbes to mouth by containing fingers or articles. By contaminated fingers or articles. So what happens if you are going to perform such activities in the laboratory or that very facility? What you will encounter is that firstly, you should, whenever you are entering inside the laboratory, whenever you are leaving the laboratory, you should always wash your hands, right? Whenever you are performing some sort of experimentation procedures, you should wash your hands. Whenever you are finishing any sort of experimentation procedures, you should wash your hands very carefully and thoroughly. So, what will happen? Ingestion hazards are mostly due to the procrastination and carelessness of individuals who are working in the laboratory because they are not working properly and they are very careless in nature. So, by mistake, you have performed some sort of experimentation in the laboratory and you are working on some sort of pathogen, right? And because of that, you didn't wash your hand very nicely, and in hurry, you left the laboratory. And from those very hands, you have started eating and drinking and smoking outside the laboratory. So, uh, these harmful pathogens will directly infect you, and after they complete their incubation time period, they will readily cause some active infection in your body. So, one has to be really very careful about ingestion hazards. Direct skin or eye contact hazard. Direct contact to biohazardous material occurs through cross contamination and mucous membrane exposure, including skin, eyes, inside of mouth, nose, and the genitalia. So one must always be sure that you don't uh, get into contact with hazardous material. The main avenue by which biohazardous material enters the body through the skin are hair follicles, sebaceous glands, sweat glands, and cuts or abrasions. Where from wherever your skin is, what is it, damaged or cracked, it will these pathogens will enter inside. They will gain entry inside your uh, body. Examples of how ingestion occur includes splash or spray of biohazardous material onto skin, eye, mouth, or nose, handling contaminated equipment with unprotected, non-intact skin. Okay, if you are having any abrasions or cuts on the skin, or any other thing, always wear gloves and waterproof dressing on. Transfer or rubbing by contaminated fingers or gloved hand. Applying cosmetics or contact lens in the laboratory. So this must be avoided at every cost. No personal contact things should be done in the laboratory. Right? Injection or inoculation hazards. Inoculation or injection occurs when biohazard material is accidentally introduced into the body with a contaminated object. Though the intact skin barrier, inadequate control of sharp instruments, and infected animals or arthropods vectors usually result in accidental inoculation or injection. Examples of injection and inoculation hazards include inoculation of with a hypodermic needle, broken glasswares, scalpels, or other sharp instruments. Sharp injuries like needle sticks, glass pipettes, syringes, etc. Animal bites, scratches, kicks, abrasions, and punctures. Agent stability and viability. This is one of the most important things that you must understand. Stability and viability refers to the ability of biohazardous material to retain its biohazardous characteristics as such as aerosol, infectivity, and survival time in the environment. Factors such as temperature, humidity, pH, oxygen, sunlight, or ultraviolet light, chemical disinfectants, growth factors, food reservoirs or media, and completion with endemic organisms must be considered. So every time you have to look into the context with these scenarios. Infectious dose. The infectious dose is the number of microorganisms required to initiate an infection. This dose can range from 1 to hundred of thousands of units depending on agent, exposure route, virulence, and host immune status or susceptibility for the disease. Concentration or amount of the agent. Concentration is the number of infectious organisms per unit volume. As the viable agent, concentration and volume increases, the risk of potential gets higher. The media reservoir laboratory activity volume, especially uh, that is less than 10 liters, needed to be considered in risk determinants. What is immune status? Immune status is the current condition of the living organism to resist and overcome infection or disease. The primary function of the immune system is to protect the body from foreign substances by an acquired ability to distinguish self from non-self. So susceptibility depends on it. If the individual is having a very good immune system, then he or she can readily deal with the infection. And if they are not having immune system up to the mark, if the individual is less than 10 years old and more than 60 years old, then he or she may have trouble dealing with these things. Laboratory biosafety level criteria. So there are four recommended laboratory biosafety levels. Biosafety level consists of laboratory practices, safety equipment, and facility combinations which are specifically appropriate for the operations performed, suspected routes of biohazardous material, transmission and laboratory functions of activity. So, uh, this is how all these things are practiced. Vertebrate animal biosafety level criteria. There are four recommended vertebrate animal biosafety levels. The recommendation below describes the practices, safety equipment, and facilities for experiments with animals infected with agents that causes or may cause human infection. So ABSL means animal biosafety level, right? In general, the biosafety level recommended for working with biohazardous material in vitro, in vivo are comparable. So, those who use animals for experimental and diagnostic purposes have a moral obligation to take every care to avoid causing them unnecessary pain or suffering. The animals must be provided with comfortable, hygienic housing and adequate, wholesome food and water. At the end of experiment, they must be dealt with in a humane manner. For security reasons, the animal house should be independent, detached unit. If it adjoins a laboratory, the designs should provide for its isolation from the public parts of the laboratory should be a need arise and for its decontamination and disinfection. So whenever the you are dealing with animals, or you should always deal with them with care, and proper food and hygiene and comfort should be provided to the animals. If you are going to finish your experiment, you should treat them in very humane manner, and you should, if they need to be sacrificed, you have to sacrifice them with the least painful way. Okay, and if the laboratory is being uh, is carrying out such pathogenic experimentation and working as a containment facility, then it should be isolated from the general traffic and general crowd. So, animal facility containment levels, summary of practice and safety equipment: ABSL 1, ABSL 2, ABSL 3, and ABSL 4. Animal facility biosafety levels, and BSC for biological safety cabinets. So, in containment level 1, ABSL 1, risk group 1, microorganisms are taken. Laboratory practices and safety equipment. Limited access, protective clothing and gloves are enough. When coming on to risk group 2, containment level is ABSL 2. ABSL 1 practices plus hazard warning signs. Class 1 or 2 BSCs for activities that could use aerosol, decontamination of waste and cages before washing. Like for risk group 3, ABSL 3, ABSL 2 practices plus controlled access, BSCs, and special protective clothing for all activities. So for risk group 4, ABSL 4, ABSL 3 plus strictly limited access, clothing change before entering class 3 BSCs, or positive pressure suits, shower on exit, decontamination of all waste before removal from the facilities. So these are some summaries that are essentially required in ABSL facilities from 1 to 4. So what are the points to consider? Agent and animal. Agent: the normal route of transmission, the volumes of concentration to be used, the route of inoculation, whether and by what route these agents may be excreted. So you all have to consider these points while you are considering the agent. Animal: the nature of the animal, that is, their aggressiveness and tendency to bite and scratch, their natural ecto and endoparasites, the zoonotic diseases to which they are susceptible, the possible decimation of allergens. So when you are choosing an animal, you must take these points into consideration. So ABSL 1, or Animal Biosafety Level 1, suitable for work involving well characterized agents not known to consistently cause disease in healthy adult humans, and of minimal potential hazards to personal handling, the animals, and the environment. So, ABSL 1, this is suitable for maintenance of most stock animals after quarantine, for animals that are deliberately inoculated with agents in risk group 1. GMT are required. The animal facility director must establish policies, procedures, protocols for all operations and for access to the vivarium. An appropriate medical surveillance program for the staff must be instituted. A safety or operation manual must be prepared and adopted. And ABSL 2. This level is this level involves practice for work with those agents associated with human diseases. It is addressed hazards from ingestion as well as from uh, precautions and mucous membranes exposure. ABSL 2 builds upon the practice procedures, containment equipment, and facility requirements of ABSL 1. ABSL 2 is suitable for work involving agents of moderate potential hazards or to laboratory personnel, animals, and environment. Laboratory personnel having specific training in handling pathogenic agents and are directed by competent scientists. Access to the animal facility is limited to the fewest numbers of individuals possible. Personnel who must enter the room for program or service purpose when work is in progress are advised of the potential hazard. Certain procedures in which infectious aerosols or splashes may create are conducted in biological safety cabinets or other physical containment equipment. So, what are other points? This is suitable for work with animals that are deliberately inoculated with microorganisms of risk group 2. Right. So, what are the precautions that are included? All the requirements of animal facilities BSL 1 must be met. Biohazard warning sign should be posted on the doors. Facility must be designed for easy cleaning and housekeeping. Doors must open inwards by self closing. Heating, ventilation, and lighting must be adequate. If mechanical ventilation is provided, the airflow must be inwards. Exhaust air is discharged outside and should not be recirculated to any part of the building. Access must be restricted to authorized person. No animals should be admitted other than those for experimental use. These should be an arthropod or and rodent control program. Windows, if present, must be secured, resistant to breakage, and if able to be opened, must be fitted with arthropod-proof screens. After use, work surfaces must be decontaminated with effective disinfectants. Biosafety cabinets classes 1 or 2 or isolator cages with dedicated air supplies and HEPA filter exhaust air must be provided for the work, and that may involve the generation of aerosols. An autoclave must be available on site or in appropriate proximity of the animal facility. Animal bedding materials must be removed in manner that minimizes the generation of aerosol and dust. All waste material and bedding must be decontaminated before disposal. Use of sharp instruments should be restricted whenever possible. Sharps should always be collected in a puncture-proof resistant container fitted with covers and treated as infectious material for autoclaving or incineration must be transported safely in a closed container. Animal cages must be decontaminated after use. Animal carcasses should be incinerated. Protective clothing and equipment must be worn in the facility and removed on leaving. Hand washing facility must be provided. Staff must wash their hands before uh, entering and leaving the animal facility. All injuries, however minor, must be treated appropriately, reported and recorded. Eating, drinking, smoking, and application of cosmetics must be forbidden in the facility. All personnel must receive appropriate training. ABSL 3. ABSL 3 level involves practices suitable for work with animals infected with indigenous or exotic agents that present the potential of aerosol transmission or and of causing serious or potentially lethal disease. ABSL 3 builds upon standard practice, procedures, containment equipment, and facility requirements of ABSL 2. All procedures involving the manipulation of infected material and infectious material are conducted within biological safety cabinets or other physical containment devices, or by personnel wearing appropriate personal protective clothing and equipment. The animal facility has specific engineering and design features. Laboratory personnel have specific training in handling infected animals with pathogenic and potentially lethal agents. So, this is suitable for work with animals that are deliberately inoculated with agents in risk group 3 or when otherwise indicated by a risk assessment. All systems practiced and procedures need to be reviewed and recertified annually. So, uh, what are the safety precautions? All the requirements of animals facility biosafety level 1 and 2 must be met. Access must be strictly controlled. The facility must be separated from other laboratories and animal house areas uh, by a room with a double door entrance, forming an anteroom. Hand washing facilities must be provided in the anteroom. Showers should be provided in the anteroom. There must be mechanical ventilation, ensure a continuous airflow through all the rooms. Exhaust air must pass through HEPA filters before being discharged to the atmosphere without recirculation. The system must be designed to prevent accidental uh, accidental reverse flow and positive pressure in any part of the animal house. An autoclave must be available uh, at the location convenient for the animal house. Where the biohazard is contained, infectious waste should be autoclaved before it is moved to other areas of the facility. An incinerator should be readily available on site, or alternative arrangement should be made with authorities concerned. Animal infected with risk group 3 microorganism must be housed in cages in isolators or rooms with ventilation exhaust placed behind the cages. Bedding should be as dust free as possible. All protective clothing must be decontaminated before it is laundered. Windows must be closed and sealed and resistant to breakage. Immunization of staff is as appropriate should be afforded. ABSL 4. This level involves practices suitable for addressing dangerous or exotic agents that pose high risk of life threatening disease, aerosol transmission, or related agents with unknown risk of transmission. So, work in this facility will normally be linked uh, with that in the maximum containment laboratory, biosafety level 4, and national and local rules and regulations must be harmonized to apply uh, the both. If work is to be done in a suit laboratory, additional practices and procedures must be used over and above standard guidelines. Precautions. All the requirements for animal facilities, biosafety level 1, 2, and 3 must be met. Access before access must be strictly controlled. Only staff designated by director of the staff establishment should have authority to enter. Individuals must not work alone. The two-person rule must apply. Personals must have received the highest possible level of training as microbiologists and be familiar with the hazards involved in their work and with necessary precautions. Housing areas for animals infected with risk group 4 agents must maintain the criteria of containment described and applied for maximum containment laboratory BSL 4. The facility must be entered by an airlock room, the clean side of which must be separated from area restricted side by changing and showering facilities. Staff must remove street clothing when entering and put on special protective clothing. After work, they must remove protective clothing for autoclaving and shower before leaving. The facility must be ventilated by HEPA filter exhaust system uh, designed to ensure a negative pressure inward directional flow. The ventilation system must be designed to prevent reverse flow and positive pressurization. A double-ended autoclave with the clean end in a room outside the containment rooms must be provided for exchange of materials. A pass-through airlock with a clean end in the room outside the containment rooms must be provided for exchange of non-autoclavable material. All manipulations with animals infected with risk group 4 agents must take place under maximum containment biosafety level 4 conditions. All animals must be housed in isolators. All animal bedding and waste must be autoclaved before removal from the facility. Invertebrates. As with invertebrates, the animal facility biosafety level will be determined by the risk groups of the agents under investigation or when otherwise indicated by a uh, risk assessment. Following additional precautions are necessary with certain arthropods, particularly with flying insects. Separate rooms should be provided for infected and non-infected vertebrates. Um, the room should be capable of being sealed for fumigation. Insecticide spray should be readily available. Chilling facilities should be provided to reduce, where necessary, the activity of invertebrates. Access should be through an anteroom containing insect traps with arthropod-proof screens and on the doors. All exhaust ventilation ducts and openable window should be fitted with arthropod-proof screens. Waste traps on the sink and sluice should be allowed to dry out. All waste should be decontaminated by autoclaving, as some of our invertebrates are not killed by all disinfectant. A check should be kept on the numbers of larvae and adult form of flying, crawling, and jumping arthropods. Containers for ticks mites should stand in the tray of oil. Infected and potentially infected flying insects must be contained in double netted cages. Infected and potentially infected arthropods must be handled in biological safety cabinets and isolators. Infected or potentially infected arthropods may be manipulated on cooling trays. So these are the MCQs. IPR is a process which protects the use of information and ideas that are rare, that are of commercial value. Which of the following are included in geographical indication of goods? All of the above. Which of the following can be patented? Uh, Machines, processes, compositions of matter, all the above. PPE kit serves as dash line of defense, last line of defense. Which of the following biosafety levels is appropriate for research with microbes or infectious agent that pose moderate risk to the laboratory workers and the community and are typically indigenous? BSL2. Which biosafety level is appropriate for research with microbes or infectious agent that pose high risk to the laboratory workers and the community and are typically indigenous? BSL4. Which of the following procedures could generate aerosols? All the above. Cell sorters, pipetting, sonegating, uh, tissue cultures. Cryptococcus neoforms would be handled at risk group. Which risk group? Risk group 1, risk group 2, risk group 3, or none of the above. The acronym of HEPA is high efficiency particulate air, high energy particle in the air, high evaluation particulate in air, protection, or hepatitis A. These are the references from where we have collected the material. And thank you very much for listening to us.